All right, guys, chapter 6 is lots and lots and lots of quadratics. So how do the graphs of 3x squared and negative 3x squared? I'm just going to plug these into my calculator, 3x squared and negative 3x squared. And if you compare them, negative 3x is reflected over the x-axis. It's just a mirror image over that x-axis. Very easy with the calculator. Number 2, it says, what is the equation of this graph? Well, let's see, let's add a new graph page. And I'm just going to enter all 4 graphs. So I'm going to do 1/4 x squared. Does not look like a match. 1/4 x squared plus 6. Not a match. It's not opening downward. Negative 1/4 x squared plus 6. Looks like it is a pretty good match at that point, but let's just check the last one to be sure. So negative 6x squared. I mean, it takes 2 seconds. Why not go ahead and plug it in and see what you got, okay? Not a match. All right? Number 3. Which graph represents a quadratic that has one real zero? Remember, zeros equal x-intercepts equals solutions equals roots. All of these things mean the same exact thing. So if we want one 0 x-intercept solution or root, 1 x-intercept, this one has 2. B only has 1. C has no solutions or no x-intercepts. D has no x-intercepts. So B is the only one with 1 perfect x-intercept. Okay? All right, number 4, we're going to skip. Inverse variation is not really something we need to know. So let's skip to number 5. Which point is the vertex of this? Well, this should be easy enough to do. Let's go look at the graph of it. X squared minus 6x plus 5. If you can't tell where that vertex is, you can turn on your grid. So I'll do that first just to remind you how to do that. You go to View and then Grid, and then I personally like the lined grid better. And so you can count it out, but even easier than that, I'm going to do Trace, Graph Trace. And as I move around this thing, first off, notice it labels, hey, that's the 0. If you forget what that is. And then when I come down here, oh, it didn't work. It didn't tell me. It should have told me that that was the minimum. You know how sometimes it was doing that and then sometimes it wouldn't? I don't know why it does sometimes and sometimes doesn't. But right down at the bottom is 3, -4. So it's got to be A. Okay? Number 6, how do these graphs differ? This is another calculator question. Let's get a new graph up there. I'm going to go x squared plus 5 and x squared plus 1. And so if you look, x squared plus 1 is narrower than x squared plus 5? No. Remember that front value tells you how steep or narrow it is. So if they're the same, it's kind of like the slope. If they're the same, they're both a 1 in front, it's not going to do anything. Same thing, wider? No, it's not narrower or wider. The graph of x squared plus 1 is plus 5 translated 4 units up. Or is plus 1 the graph of plus 5 translated down? This is a reading issue, okay? You've got to read very carefully. Plus 1 is the lower of plus 5, okay? Read that over and over and over again until it makes sense to you because it's worded oddly. Number 7. They've graphed it for you and they say, what is the solution? Remember, it has to equal 0, okay? That's key. And this is really helpful that it already equals 0. So the solutions, there's 2 of them. I got one right there and one right there. I just got to figure out where they are. Well, that looks like +2 to me. That looks like -6 to me. So B, okay? The y-intercept is not a solution. Ignore that. That does not count. Number 8, what are the solutions to this one? Okay, I just said it has to equal 0. Quadratics have to equal 0. So if it doesn't equal 0, I'm going to go ahead and subtract 24. So I get x squared minus 2x minus 24 equals 0. Now, the easiest way to find solutions is to go look at your graph, okay? So let's do another graph page. And I'm going to type in x squared minus 2x minus 24. And I'm going to look at that graph. And if I'm looking for solutions, I got one here and one way over here. I can count them out, or I can always do trace. And I'm just going to graph trace this. It starts on your y-intercept. So I just have to keep going. One of my zeros, oh, past it. One of my zeros is at -4, so I know I have to have -4. And honestly, I don't even have to go look at the other one because that's the only answer choice that has -4. But if I really want to be careful and make sure I get this question right and I didn't do anything stupid, I'm going to go ahead and trace all the way over there. I wish there was a shortcut. By the way, did you see that that time it did pop up and call it the minimum? I don't know why. Sometimes it does and sometimes it doesn't. All right, so my other 0 is at 6, which is totally perfect, okay? What are the solutions of the equation x times 4x plus 3, 3 times x minus 3? Lots of different ways you could do this, okay? I'm going to first, though, take the whole thing of I need it to equal 0. So let's distribute here. I'm going to get 4x squared plus 3x on one side. And when I distribute over here, I get 3x plus 9. I need it to equal 0. So I'm going to subtract 3x. And I'm going to go ahead and do this in the same step. I'm going to go ahead and subtract 9 also. So now I get 0 over here. Both of those have canceled out. Combining like terms. 4x squared doesn't have any. 3x and -3x actually cancels out on this side too, which doesn't always happen. And then minus 9 equals 0. Shortcut testing stuff. There's a lot of ways you could go about this, but once I have a quadratic, because it has squared and it equals 0, the easiest way is to go look at your graph, okay? So I'm going to say 4x squared minus 9. I don't have to put equals 0. That's kind of this f of x thing is equaling it. So 4x squared minus 9. I'm going to look at my graph. I can either eyeball those solutions, or I can always do graph trace. Menu 5-1. And so if I go back to this side, I get -1.5. You kind of have to know that that's -1.5, okay? I hope we do at this point. And then you can kind of tell that it's symmetrical, so it's going to be +1.5, but you could scroll over there if you wanted to. But C is the answer, okay? Come back for the rest of this one.